Chapter 1 of Algebra 2. This should, to a large extent, be a review of what you learned in Algebra 1, but we're going to cover it anyway to make sure that you remember it. To start with, we are going to deal with Section 1.1 is applying properties of real numbers. There are imaginary numbers. We will talk about these more later in the course. For now, we're going to deal with just the real numbers. And the real numbers can be broken into two groups. We have the rational and the irrational numbers. And again, in the first half of the course, we're mostly going to be dealing with rational numbers, which can be broken down into a smaller subset of integers, which can be broken down into an even smaller subset called the whole numbers. So rational numbers is a number that can be written as a fraction of two whole numbers, so 3/8, which could also be written as a decimal of 0.375. Another example of a fraction of two whole numbers could be 2/9, which could be written as a decimal of 0.222 repeating. So a rational number, though, is commonly thought of as a fraction, number that can be written as a fraction. It can also be a decimal. However, that decimal must be a terminating or a repeating decimal. Next, we come to our integers, and the integers are the positive and negative whole numbers from negative infinity to positive infinity. So they don't include any decimals or fractions, just all of the whole numbers, positive and negative. And then finally, our smallest subset that we're going to deal with is the whole numbers, which are the counting numbers, the positive counting numbers, including 0. So 0, 1, 2, 3, all the way up to infinity. Irrational numbers are numbers that cannot be written as a fraction. In decimal form, they would be non-terminating, non-repeating decimals. So example would be the square root of a non-perfect square number, like the square root of 2. Or pi is a very popular, famous, irrational number. Now we have our properties of addition and multiplication. So we have the commutative property, and just like when you commute to school or home, it doesn't matter which way you're going, the distance is the same. So a plus b is the same as a or b plus a. Same with multiplication, a times b is the same as b times a. The associative property, if there's a group of you that are riding to school, again, it doesn't matter which order you're going, where you're sitting in the car. You can have a plus b plus c in the back seat, or you can have a and b plus c is in the back seat. Either way, all three of you are going to get to school. It doesn't matter how you group them. And again, that holds for multiplication. So a times b in parentheses times c is the same as a times b times c. Then we have the identity. The additive identity is 0. If you add 0 to any number, you still get that number. And the multiplicative identity is 1. So any number times 1 will still give you that number. And the inverse. The additive inverse means that you're adding a plus the additive inverse gives you 0. Multiplying is a times the multiplicative inverse is going to give you 1. The additive inverse is usually referred to as the opposite, and the multiplicative inverse is called a reciprocal. And then we also have the distributive property, and we distribute multiplication over addition. So a times b plus c in parentheses is the same as a times b plus a times c. The definition of subtraction and division. Subtraction by definition is simply adding the opposite. So a minus b is the same as a plus a negative b. And division by definition is simply multiplying by the reciprocal. So a divided by b simply means a times 1 over b, or the reciprocal of b. And now we come to unit analysis, and this is checking to make sure that the units in your calculations make sense. So if you work for 8 hours and earn $60, what is your earning rate? You usually think of an earning rate as dollars per hour. Remembering that per means to divide, you could write this as dollars over hours. And now you're just plugging in the right numbers in the right places. So $60 divided by 8 hours. When I divide this out, I get $7.50 per hour. Another example, you buy 18 gallons of gasoline at $2.65 per gallon. What is your total cost? Well, remembering that total cost is just money, but both our quantities have gallons in them, so we need to figure out how to get just money. Unit analysis allows us to make sure that our proper units are canceling out. So if I take 18 gallons times 265 per gallon, you'll notice that the gallons on the numerator and the gallons on the denominator cancel. When I multiply my numerator across and my denominator across, I'm going to get $47.70, just money. And finally, I drive 90 kilometers per hour. What is your speed in meters per second? So we have a lot of things we need to change in this problem. Let's start out with what we know. We know we have 90 kilometers per hour. We need to convert hours into seconds. So first of all, we can convert hours into minutes. 1 hour is 60 minutes. I'm really just multiplying by 1 because 1 hour equals 60 minutes. And I know that my hours has to go on top because it has to cancel with the hour of the denominator. I also know the conversion of minutes to seconds. 1 minute is 60 seconds. Again, the minutes have to go on top to cancel with the minutes that I already have on the bottom. And now the kilometers. I need the conversion for kilometers to meters. So there's 1,000 meters in 1 kilometer. And again, I need to make sure that I put the kilometer on the denominator because in my very original fraction, kilometers on the numerator. So now I can double check this. My hours on the numerator and denominator cancel. Minutes on the numerator and denominator cancel. Kilometers on the numerator and denominator cancel. And I'm left with meters on the numerator per seconds on the denominator. When I multiply across the numerator, I get 90,000 meters divided by 3,600 seconds. And when I divide that out, I get 25 meters per second. That's a super quick rundown of section 1.1. If you need a better explanation or more examples given with the explanation, please refer to the video on my website. Otherwise, make sure you come to class and ask any questions there. See you then.